Okay, I think we're live. So, yeah, good morning, everybody, and good morning and welcome to the last of our Zone breakfast series for this year. It's a brilliant opportunity to welcome two friends, so Ed Hanna from University of Lincoln and Robert Cordwell from Ada. The subject of today's session is meeting the challenges of farming in a changing climate. Again, it's a really exceptionally topical subject matter for farmers. I mean, I speaking to one farmer, I think 2 months ago, who said he's now experienced 6 1-in-100-year weather events in the last 6 years. So it really is very, very serious. And I think these extremities of climate change are really starting to hit us and hit us hard. And one of the big things is water. It's great to have Robert here. I mean, Robert really is on the front line, literally, and was impacted in the 2013 storm surge with some land lost at Jubilee Bank out towards Friscony, and has also been very heavily involved with the issues around the river steeping flooding in 2019 and other issues across the whole county. So I think we're all in debt to Robert for the work he's doing. He's going to give us a good overview on where we are and what the situation is. So that's this session. So please, when we go through, if you've got any questions, please put them in the comment box, and I'll take them and introduce them as quickly as I can through the session. So the more questions, all questions, warmly welcome. So just a quick update from Rhizome. I mentioned on previous sessions that we're really making progress on the old hall renovation, and what I want to show here is just a picture for the first time, just to show it really has happened. And if any of you remember the old hall, it was looking a bit tired and a bit dated. Hadn't really been had any money spent on it for many years. And this just sort of shows what it looks like inside now. So we go back in, subject to coronavirus, of course, after Easter, and this is what it's like. It's absolutely fantastic. And our colleagues in estates at the university have done an absolutely fantastic job. So it's redecorated, refreshed. It's now a digital hall with a new roof, and it's hopefully will be a great asset for Lincolnshire agriculture for another 100 years at least, particularly with the roof renovations gone on. So we're looking forward to going back, and I think our first breakfast briefing of season 21-22, subject to coronavirus, and I think by getting more and more hopeful, we really are genuinely looking forward to welcoming everybody back for a face-to-face session in the old hall, and perhaps a bit of a celebration of the whole old hall itself. So that's a quick update. So yeah, fantastic. Now, without further ado, I'm now going to hand over to Ed, who's going to talk about climate change, melting ice, rising sea levels, and extreme weather in and around Lincolnshire. So Ed's professor in the School of Geography, fellow Royal Meteorological Society. Ed's got a world class, and it's often widely used terminology, world class, but Ed really is a track record in meteorology, particularly monitoring issues like sea level change, impacts of changes to the ice sheets, and more on long-term weather generation, weather forecasting. And then Ed's recently got a huge grant from UKRI NERC to look at seasonal range weather forecasting, so long-term weather forecasting. And one of the outputs will be impacts on agriculture. So absolutely bang on and very important. So without further ado, I'm going to hand over to Ed.
Thanks very much, Simon, for that introduction, and thanks everyone for attending this virtual online event. So it's vital that we all try and continue to keep in contact with each other during these extended lockdowns, and this is a very good way of doing that. So Simon's already introduced the title of my talk, so I'm going to cover quite a few subjects. I've got about no more than half an hour maximum, so I'm necessarily going to have to be quite selective. So I'm going to talk about climate change and its links with extreme weather events, with a local focus in and around Lincolnshire, and also the impacts of climate change. Apart from the extreme events, sea level rise is obviously a major key impact, and that's one that particularly affects Lincolnshire. So I'll very briefly, I'm sure you've seen some of this information before, but I'll very briefly just talk about updated information on how the climate's changing, but then I'll focus more on the extreme impacts, on the key impacts on extreme weather and sea level rise that particularly affect Lincolnshire and the UK, and how we can address the climate crisis. I'll briefly address as well. And then I've got a few slides towards the end with my the new Natural Environment Research Council. So it's a UK government funded project that Simon, myself, and various other universities, the Met Office, have just started in looking at trying to improve seasonal weather prediction. So I'm sure you've all seen graphs like this, which is showing levels of greenhouse gases in the Earth's atmosphere. So these two graphs here are showing levels of atmospheric carbon dioxide concentrations in the atmosphere in parts per million. Hopefully you can all see the mouse pointer here. So we've had something like a 50% increase in the atmospheric carbon dioxide since pre-industrial. So this lower graph, this is shown for the last 60 years or so. And you can see it's a exponential rate of increase, an accelerating rate of increase. We're now something like 416 parts per million in Earth's atmosphere. Pre-industrial, you can better see the pre-industrial levels from the top right graph that actually goes back from the present day, back for the last 800,000 years. We were something like 200 and 280, between 180 during the ice ages and 280 during the interglacial. We're now above 400, so that's a huge increase. You can see we're well outside the range of natural variability in the last million years or so of atmospheric carbon dioxide concentration, and that extra greenhouse gases, this comes from human activity, and this is very well established through lots of measurements from mountaintop observatories such as the one in Hawaii that is shown here. And then basic physics says that if you have more of these greenhouse gases, it's not just CO2, but there's also methane, there's other greenhouse gases in the atmosphere as well, then you increase the amount of long wave radiation, infrared heat that's trapped near the Earth's surface in the lower part of the atmosphere, and that has a resulting effect on the global average temperature. So you can see here, this is each red dot is a yearly value of the global average temperature. Records go back based on instrumental weather stations all around the world and ships and so on, back to the mid 19th century. So we've got about 170 years worth. Again, you can see an accelerating rate of increase of global temperature in the last few decades. And in the last 10 years, we've had successive record values that are way above the range of natural variability. If you look at longer versions of this graph, we're well outside the range of variability of the last 10,000 years or so, at least, of temperature records, temperature data. But of course, it's not just the change in the average state of the climate that's changing, but also we've seen more extremes. And there have been a number of studies in the last 5 or 10 years that have directly attributed increases in the number and severity of many weather and climate related extremes. So that's the red and green lines and the blue lines, the hydrological events shown on this graph. They've all increased in the last 4 decades since 1980. So this is based on Munich Re data, the global reinsurance company. This is the most up-to-date graph I could find recently. So it's taking data up to a couple of years ago. But the yellow line is basically, it's adding together all the various types of events, and most of these types of events, which are largely driven by weather and climate, except for the purple ones, which are geophysical events, which haven't increased. Those are earthquakes, volcanoes and tsunamis, but all the other events have increased in terms of their impact, severity, number of them, their economic impacts over that last period. And you can see some selected headlines from Munich Re from last year, from 2020. So record hurricane season in the North Atlantic, and of course wildfires, historic wildfires in California and the Western US. You can see basically these impacts are operating at the global level, in many cases in densely populated mid-latitude regions all around the hemisphere and in the southern hemisphere as well. Of course, we always have had extreme events, and some people listening in, well, in fact, you'll all be familiar with this, people local in Lincolnshire, but some people may have experienced it directly. Obviously, this was a very major impact in terms of land flooded, homes lost, and lives lost actually as well. In England, over 300 people killed from the North Sea flood event of January, February 1953. So there was a storm surge down the North Sea. You can see the low pressure here, and that basically piled up water against a large swath of the east coast, all the way from Scotland right down to the Thames estuary and Kent. And obviously the Netherlands, there were, I think, about 3,000 people killed there. So the impacts were even worse there, but pretty severe impacts locally in Lincolnshire. So we always have had the extreme events, but they obviously we got sea level rise as well superimposed on the climate warming, so it's a double whammy effect. So we can expect more events. I think this is something that Robert might touch on later in his talk, but the storm Xavier that gave a similar, but luckily we had slightly better coastal defences than in 1953. But a broadly similar effect of a North Sea tidal surge flood in December 2013. And this picture is showing the stump in Boston. This is where we regularly take our students from geography on field work. We're planning to take them, if restrictions allowed, just after Easter, to look at evidence of historical marks of flooding. So this is from a relatively recent event, just 8 years or 7 years ago. And of course, you'll all be far more familiar than me. I'm not native to Lincolnshire, but I've now been round bits of the county and visited some of the seawalls and so on. But of course, Lincolnshire, you'll know far better than me, many of you, that they're obviously very vulnerable in terms of lying very close to sea level. So this is a scale, sorry for the imperial units, but it's in feet. And then you can see lots of blue colours. So obviously it's very vulnerable and moving inland, even towards the city of Lincoln. And so some of the rivers that come through Lincoln and go towards the coast, that you can get inland river flooding, but also increasingly with sea level rise, is impacting these very low-lying coastal areas as well, with saltwater ingress and storm surges and the effects of those as well. So the red dot is Boston, and Lincoln is up here with the yellow dot. So sea level rise. Sea level is rising at an increasing rate in line with the increase in global temperature. So during the early to mid 20th century, so the first this left-hand part of the graph, the average rate of sea level rise was just under 2 millimeters per year. But in the last few decades, that rate of sea level rise has increased to 3.5 millimeters per year. And it's likely to increase further during the next few decades. And the reasons for this are melting ice from lots of small mountain glaciers, which are rapidly disappearing all around the world, but also the 3 giant ice sheets. So there's 1 in Greenland and 2 in Antarctica. But also, as seawater gets warmer, it naturally expands. So you've got thermal expansion of warmer seawater. So there's several effects that are leading into this sea level rise. And so if you look at things like the Climate Central website, this is shown for not a particularly pessimistic scenario, but just for a mid-range sea level prediction by the end of this century. And I often say to my students that many of them will still be alive at the end of this century. I won't, but many of them will be. So they're actually left to see the accuracy of these being borne out or not. Then these pink areas are extremely vulnerable by the end of the century, and that's even without an added local flood. That's just from the mid-range sea level projection, and this is according to a mid-range intergovernmental panel on climate change greenhouse gas emission scenario called RCP 4.5, which is in the mid-range of a wide range of projections. So it's saying that by the end of this century we get to something like 2 degrees Celsius above pre-industrial global average temperatures. What you've got to remember is that we're currently already over a degree above pre-industrial temperatures. So that's saying that the global average temperature only goes up about 0.9 degrees more than it is today. So, and we could get obviously a higher emissions scenario situation than this, and a greater degree of warming quite easily by the end of this century. So this isn't an unduly pessimistic scenario, but it shows the sort of level of vulnerability of Humberside and Lincolnshire, and moving down into parts of Cambridgeshire and East Anglia. As I said, one of the main factors causing sea level rise is melting ice. So one of my strands of research of my group is looking at the recent rates of change of mass of all three ice sheets. So there's 2 ice sheets in Antarctica. That's shown by the graph on the top right here, and the scales is in is mass change in billions of tons per year, gigatons per year of mass change over the time period, well, the last 30 years. And the blue line is giving you a yearly rate of mass change, and then all the different coloured boxes are different estimates of the mass change of the ice sheets in Antarctica. Well, we're losing something like, on average, in the last 15 years or so, something like 150 billion tonnes per year from Antarctica. And if you look at the lower graph for Greenland, again, the blue line is showing you the year-to-year mass changes, or one estimate of those. Then we're losing something like 250 billion tonnes per year from Greenland, averaged over the last 15 years. So if you add together those ice sheets, that's something like 400 billion tonnes of ice mass per year that's been lost just from those 3 big ice sheets. And that's contributing currently about a third of the global sea level rise. And because of certain vulnerabilities of the ice sheets, those contributions are likely to increase potentially at an exponential rate going forward for the next few decades. So that's one to watch out for, particularly with Antarctica. It's a bit like a sleeping giant that's gradually awakening, and it probably doesn't need that much extra warming, and you can destabilize some quite significant parts of the marginal zones of Antarctica and lose a lot more mass very quickly, according to some recent studies. And Greenland is similarly vulnerable. What we're also seeing, because I study these high latitude areas such as the Arctic, shown here quite a bit, is that we're losing the sea ice in the Arctic in particular in the last few decades. So the lines here are shown for winter sea ice in black and summer sea ice in red. In late summer, in the month of September, we're losing something like, we've lost actually over half the sea ice cover since 1980 or so. And if you bear in mind, the ice is not just shrinking this way, it's also getting thinner as well. So we've lost something like 3/4 of the volume of the Arctic sea ice, which is shown with the white colours here for a typical summer configuration of the sea ice. Now, as that's shrinking and getting thinner, you're radiating much more heat from the ocean to the atmosphere, particularly during the late summer, the autumn and the early winter. And that is accelerating the rate of global warming across large parts of those high latitude regions. So in the Arctic, and also to slightly lesser extent, but still happening in the parts of the Southern Ocean surrounding Antarctica. So that's an amplification mechanism that is accelerating global warming. And just to give you some idea of why that happens, if we look at this picture here, this is just taken out a plane window when I was flying back from a meeting in Alaska a couple of years ago. But this is in almost just after our midsummer in the Northern Hemisphere. So you can see the ice flows, the sea ice flows. This is in the Beaufort Sea. So this is about 80 degrees north latitude. There's always some sea ice left in the Arctic in summer, but that's rapidly shrinking on a yearly basis. And you can see that as you lose that ice, it's much brighter and more highly reflective. Then you get much darker areas of ocean water, which absorb more heat energy from the sun, which also heats up large regions of the surface. So there's a number of what we call these feedback processes that are accelerating global warming effectively all around the planet, but focused in these high latitude regions. And this is, again, some work I've done with the American Met Service called NOAA. But this is a report we recently produced that's freely available online called Arctic Report Card. It's an annual update of climate conditions in the Arctic. And if you look at the rate of warming, global warming in the Arctic, or warming north of 60 degrees north, that's shown by the red line. You've got time scale at the bottom. And that's a much greater rate of increase. It's about double the rate of global warming in the Arctic in the last 20 or 30 years through having these amplification processes, a couple of which I've just mentioned. So that in turn, what that does is if you have very strong warming near the poles, that can change the balance of heat north-south, because if you're warming the poles more rapidly than regions nearer the equator, you're reducing that gradient of heat between the equator and the poles, and that is that heat engine, if you like, that drives the jet stream, which is this yellow ribbon shown here. So it's basically a current of air in the atmosphere in the middle latitudes. There's one in the southern hemisphere as well. In fact, there's two in each hemisphere. We're looking at the northern hemisphere polar jet stream here, that generally flows from west to east, but it always has some degree of waviness. But as you warm the Arctic more than the tropics, you're reducing one of the main sources of energy for driving the jet stream. So that means that for longer periods of time, it becomes more sluggish and wavier. So it's a bit like a river meandering across a floodplain. When the gradient gets shallower, that it slows down and becomes wavier. And this means that you can get more stuck weather patterns near the Earth's surface. So, for example, Hurricane Sandy in 2012 got pushed into New Jersey and New York. It was a very unusual track for a hurricane. They normally recurve out over the North Atlantic because of this very wavy and stuck jet stream. So that had a direct impact on New York, and there's studies that attribute that impact on New York to climate change. So that's just one example, and there's many others. From observational data, these are bird's eyes view on the North Pole. If you look at the configuration of the jet stream, which is marked by these are streamlines of airflow. So the boundary between the dark blue and the light blue is marking the path of the jet stream, which flows anti-clockwise around these maps. Then you can see that in the region near the top of the map, it's relatively wavy in the left-hand map compared with the right-hand map. So the left-hand map is showing June, July, August, so mean summer conditions, average summer conditions for the last 14 years, 2007 to 2020. If you look at a climatological baseline, so summers 1971 to 2000, you've got a much more uniform, linear or zonal jet stream compared with the recent summers. So when we looked at observational data, this seems to bear out the idea that I've just mentioned of getting, for longer periods of time, a wavier jet stream in recent years. And another aspect of changes in the atmosphere that's linked with that is having, in summer, higher air pressure over Greenland. You can see the red blob here is showing for recent, again for summer in the last 13, 14 years, that if you take the difference in air pressure between those recent summer conditions and the late 20th century summer conditions, then you've got higher air pressure over Greenland. You've got a blue blob over the UK on average. The air pressure on average has gone down, not all the time, but on average we're getting lower pressure in summer over the UK. So something that I've really sort of worked with on an international basis and sort of looked at how this has been changing is this measure of high air pressure over Greenland. And we've had record high values of this in the last 10 or 15 summers compared with the last century and a half or so. So something called the Greenland Blocking Index, which is a measure of how much high pressure there is over the Greenland region. So again, those data, if those are archived by the US Weather Service, NOAA, and the impacts of getting these changes in air circulation in summer over the North Atlantic are having wetter summers over Northern Europe and the UK. You can see on the lower right plot here. In winter, if you have more Greenland blocking the top left plot, then you get colder air masses coming down from Scandinavia and Siberia. And certainly we saw that a few weeks ago here when we had the Beast from the East 2 event, or the Beast from the Baltic, with some cold air and snowfall locally. So changes in the jet stream have effects downstream in other parts of the world, and what happens over the Arctic doesn't stay in the Arctic, but it can quite fundamentally affect the chance of getting extreme weather conditions and flooding and hot and dry spells and so on over Northwest Europe and the UK. And in fact, one event that I'm sure it'll be mentioned later is the Wainfleet floods in June 2009, and you can see that if you look at the rainfall anomaly map for the UK, we had these bright blue colours over much of Wales, central and eastern England, where we had double the average June rainfall in June 2009. And again, that was linked to high air pressure over Greenland, the second strongest anticyclone for the month of June in the particular data set that that I'm plotting here. So and what that does is to push the jet stream further south than normal over the North Atlantic. So you've got a purple blue blob over the UK region, lower air pressure. So the jet stream has been pushed down, squeezed down further south over the UK. And so that was a direct cause of these this flooding episode at Wainfleet. And then many records have been broken in the last few years. So not this winter, but the previous autumn and winter, 2019, 2020. Again, very wet conditions over Lincolnshire, something like almost double the average rainfall. And again, linked with high air pressure over Greenland, a further south jet stream over the North Atlantic. And the University of Lincoln, just across the Brayford Pool, this is the main sort of walkway there that got flooded. The university, the main campus, just managed to avoid getting flooded, but it was a near miss. And of course, I know that some probably people listening in got very badly affected by those floods of just over a year ago. And in fact, during the same winter, the February 2020 was the wettest month of February that had ever been recorded in the UK instrumental records, and we had a very vigorous jet stream going all the way around the hemisphere here, with some windstorms as well. This is because I live in Newark, and this is actually just a few hundred meters away from here. But you can see exceptional rainfall levels, so something like 2 or 3 times, even 4 times in places the average February rainfall. On the other hand, we've had some very cold wintry spells during in the last few years, or last 10 years or so. So this happened in 2009, 10 and 11, but also in February, March 2018, when we had the Beast from the East and snowdrifts on the East Coast. And I'm sure many of you will remember places like, I think Skegness was actually cut off for a couple of days because the roads were inundated with snowdrifts. So what we're seeing in winter is we're seeing an increased year-to-year variability of the jet stream as measured through, for example, I'm sure many of you will have heard of the North Atlantic Oscillation Index, which is a measure of it's a air pressure index. It measures how strong the westerly winds that reach the UK are. So if you look at the year-to-year variability of that, that's almost doubled. It's a highly statistically significant increase in variability. And that's led to more extreme events at opposite ends of the spectrum. We still don't understand what's caused this, but there's a number of factors. Climate change certainly is a contributory factor, I believe, here. Last few slides. So we're getting warmer and are likely to get have more major climate changes going forward for the rest of this century. So these 2 plots are from the Intergovernmental Panel on Climate Change, showing for a low on the left panel and high emission scenario on the right panel, the changes in temperature that we can expect, or the extra changes, I should say, in temperature and precipitation at the bottom that we can expect during the rest of this century. So it's quite frightening, really, looking at the business as usual emissions scenarios, something like between 3 and 10 degrees extra warming compared with recent levels, depending on where on the planet you are. But the hydrological impacts are even more profound. The wet areas tend to get wetter. The dry areas, especially the subtropics, the Mediterranean, those kind of areas tend to get drier. But certainly we can expect more serious changes. And if you look at what the Intergovernmental Panel on Climate Change were publishing in their recent reports, there's another report that's going to be coming out next year, but their last interim report, looking at sea level rise, for example, they were a bit more pessimistic regarding sea level rise being faster than previously predicted 6 or 7 years ago. So we could be looking quite easily under a business as usual scenario over a metre sea level rise or more by the end of this century. And in fact, because of uncertainties with the ice sheets, some of these ice melt from Antarctica could go up to potentially 2 metres sea level rise. It's a low probability, low chance of it happening, but we can't exclude it because we still don't understand enough about how the ice sheets respond to climate change. More probably, we're looking at this solid grey range, but you can see even within that range, you can easily get more than a metre sea level rise under a relatively unlucky scenario by the end of this century. So that obviously has major impacts locally as well as globally. So how do we address this? Well, very briefly, the university, together with the City of Lincoln Council and other public sector bodies and other business stakeholders and so on, helped set up the Lincoln Climate Commission a couple of years ago to try and reduce the City of Lincoln's carbon footprint. We're also working with the wider county of county council as well. So this is chaired by Councillor Rick Metcalf, the City of Lincoln Council leader, and they recently adopted, or the City of Lincoln Council recently adopted, a net zero carbon target by the year 2030, which is tremendously ambitious. And this was significantly influenced by research going on within geography and other parts of the university that influenced the council's decision to adopt that target. Within the university, I've recently set up the Lincoln Climate Research Group. You're all very welcome to attend the meetings. We meet once a month or so. We just head out inaugural meeting. So we address the physical, social, environmental, and political causes and drivers of climate change over all range of scales, from local through regional to national and global. And there's a website. If you just Google Lincoln Climate Research Group, you'll come across it. And do email me if you've got any questions about any of our current projects. Last couple of slides, just very briefly mention the NERC research grant that Simon and I have together with 4 other universities. So Reading, Sheffield, Oxford. We've got the Met Office. We've got the European Centre for Medium Range Weather Forecasts. So the idea is to use machine learning, so artificial intelligence methods, to try to improve current forecasts of the seasonal forecasts over actually the whole of Northwest Europe. So forecasts of temperature and precipitation looking a few months ahead based on our prediction of how the jet stream is going to be changing during the next few months. But importantly, we plan to engage we've got some partners, key partners in the agri-food industry, and one of the main objectives of this project is to demonstrate the practical benefits of improved seasonal forecasts and enhance their uptake by potential users. So I think with that, I'll end there because I've taken my allocated time. But if anyone has any questions, don't hesitate to email me. Thanks very much.
Ed, thank you. That was absolutely superb. It's wonderful. And thank you so much for the work you're doing and giving us such an excellent overview. It's compelling. I was absolutely captivated for the last 30 minutes listening to you and thinking, goodness, we've got some, we've got some major challenging problems to deal with. I mean, do you think we're doing enough, Ed? Society is doing enough to respond to this?
Well, I think the situation is better than it was even 2 or 3 years ago. There's a lot more we can be doing, but at least people are talking seriously about it now. And I think one of the encouraging things is that it hasn't gone away despite all the COVID issues that we've been dealing with recently, I think there also might be lessons that we can learn from how we've been dealing with the pandemic, that we can address really serious issues quite quickly if we want to, that we can use to address the climate crisis.
Yeah, no, I agree, and I was just struck 400 billion tons of ice melting. How much is there? How long can it go on for? It just seems like an extraordinary mass that we're losing.
Yes, I mean the ice sheets have been there for millions of years, but we could be talking about the whole of the Greenland ice sheet, for example, disappearing in the next 1,000 years because of what we're doing to the atmospheric system. So 1,000 years is nothing geologically speaking, so that's a massive change. But obviously the sea ice, which is much more vulnerable, it's only a few meters thick at the most, that's already almost gone in the Arctic in the summer, so that could disappear entirely in the next couple of decades in summer. There'll still be some in winter, but yeah, these are big changes, rapid changes. So it's a good thing that we are taking things more seriously in the last couple of years. A lot more still to do, but yes, plenty of ice. But the smaller glaciers, some of them are disappearing in a matter of decades or centuries, of course.
Yeah. Okay. And bring it back more locally. And I know Alan's put a great comment in the chat. So anybody, please, if you've got comments, just fire them into the chat. So Alan's comment, thanks Ed for straightforward, factual, excellent data that's challenging story for policy mitigation, protection of land and houses nationally and locally. So if we bring it back to Lincolnshire and policy and mitigation, what do we need to be thinking about?
Well, I think there's a whole range of issues, but I think the hydrological changes and the sea level rise obviously directly impact large parts of the county. So I think the Lincoln Climate Commission is a great first step. I know that there's other projects that many people listening in and the university and key stakeholders are engaged in with looking at flood resilience of different parts of Lincolnshire, for example. So those are absolutely crucial. And I know that you're involved, or members of your team, Simon, with the sulphur project, for example. We're looking at salt poisoning of agricultural lands. And again, some farmers listening in might be key stakeholders in that. So I think ramping up this kind of activity moving forward is going to be crucial, because obviously I think a key aspect is how climate change is so evident at the local level. And where I used to work previously, you could see this just by looking at the main weather station record in Sheffield, which just happened to have the longest running weather station in Yorkshire going back to the early 1880s. And when you actually match the temperature record from Sheffield against the global record, they correlated very well indeed. So that was a very good demonstration. I always used to use that in teaching of global warming and climate change happening on our doorstep. So and yeah, I think it's quite fascinating, but also quite worrying. But I'm confident that with a collective response, we can at least mitigate and adapt to many of these issues and reduce their worst impacts. So I'm quite confident that we have the ability to solve these problems if we come together collectively. I don't think it's any one part of society that can do it. It needs to be everyone buying into it, really.
Yeah, and funding, I guess, isn't it? I have some insight into what happened in the Dutch, the investment in the Dutch sea defences, which has been extraordinary, isn't it? And so it can be done, but funding is going to be a big challenge for us in Lincolnshire, I guess.
Yes, I mean, I think that's absolutely right.
Yeah. All right. Thanks. Just one from Tulip Tree 2. I think it's JH. So Ed, the UK Climate Change Commission and many others think we have about 10 years to make significant change to actual reduction. So much more than policy. Do you agree?
Well, yes and no. If we do need to make significant reductions in greenhouse gas emissions in the next 10 years to fulfil longer term objectives. It's going to be much harder moving forward if we don't. I think hopefully we're on track to achieve quite a bit of that through obviously technological changes and policy changes. So I think all these things have to go hand in hand. I don't think there's an exact timeline. I just think we need to do things as quickly as we can, but in a sustainable way. So things that are socially, economically sustainable. We carry all of society with us because we don't want to be divisive about this. Because one of the problems before is, for example, if you invest in renewable energy, then you have to buy into the technology, and that can leave out people who can't afford to have that technology sometimes. So I think if we can do it in a way that we can have buy-in from everyone, then it is achievable. But industry will be and is already leading the way. So things like electric vehicle rollout, for example, it's only a small part of the solution, of course. But I mean, I think fundamentally, if you have a petrol or diesel vehicle, it's years are numbered in terms of the technology is going to be completely. There's going to be a jump in the technology. It's already happening. But things like how you improve heating, in homes, that UK homes aren't always very energy efficient, or quite often they're pretty old drafty buildings, aren't they? And how you actually change gas boilers over to heat pumps and air source pump boilers is more challenging. But I think it needs a whole scale solution.
No, I think it's quite interesting. I think Lincolnshire's leading the way. With offshore wind particularly. I mean, it just strikes me, and I think I'm right, but I think in a year or two's time, there'll be more power going into field in Bicker Fen than Sizewell B power station because of off-wind generation and international connectors coming into Lincolnshire. So anyway, that's good stuff. Right, Ed, I'm going to thank you there, and I'm now going to hand over to Robert, who's got experience really on point at the sharp end of what you just talked about, Ed. So, Robert, without further ado, thank you.
Thank you, Simon. That's brilliant. Thank you, Heather, for the first slide. Just some context around that. I'm currently chairman of the Association of Drainage Authorities. Prior to that, I was a regional committee chair for the Environment Agency from the Humber down to the bottom of Northamptonshire from 2005 to 2015. But my background is farming, and we farm in South Lincolnshire between Boston and Skegness, right on the coast. So quite a lot of what Ed was saying there was pretty scary for farmers like me. And that's something that we certainly saw in 2013, the surge tide, which, as Simon said originally, had burst through the Jubilee Bank and flooded 600 acres of high-grade farmland there. Fortunately, there was a secondary bank, and so the floodwater didn't go any further. It was eventually pumped out, and the land is still gradually recovering from that, because of course inundations of salt water do have probably more impact than and a longer time for the land to recover than maybe some fresh water. But I am not in the least lessening the impact of flooding on farmland is a real problem that I want to try and talk about. And in the context that Ed has talked about in terms of climate change, Sir James Bevan, who's Chief Executive of the Environment Agency, gave a talk a couple of weeks ago and said net zero on carbon is not enough. We will have to adapt. And that is going to be absolutely where we at ADA feel that adaptation is absolutely key. I've titled this Threat to Food Security because most farmers that I talk to and farming organisations are concerned about the food security. We're in a world, and this is a global issue, as Ed has set out, where every year there are 76 million mouths more to feed. By 2050, we will have a global population of 9 billion. Tonight, there will be over 1 billion people suffering from severe malnutrition. Food production is absolutely vital. Yes, of course, we have to reduce the waste, and we have to make sure that it can be transported to the people who need it. But we are a small country. We only produce 64% of our own food at the moment. So we do rely on other parts of the world to supply a great deal of the food that we actually consume in this country. And when you think last year, flooding, I mean, we can see on the news today that the dreadful floods in Australia. Last year, there were 20 million acres of farmland flooded in the US. Every year you will see farms seriously affected. This 2007 floods, 100,000 acres of farmland were flooded. The agency Environment Agency recently announced that they have been able to move 300,000 properties in the last 6-year programme. So that's £2.6 billion of government spending. 300,000 properties moved to a lower level of flood risk, along with 64,000 acres of farmland. The next 6-year programme, government are investing £5.2 billion in terms of their capital programme. Is that enough? I think at the end of the day, we have to be seriously questioning that. We need to be making sure that it's still a very small amount, considering the risk and that the amount that it is increasing, and also the cost. When you look at actually when flood events happen, the cost to UK PLC is horrendous. So can we move on to the next slide, please, Heather? Ed mentioned about Wainfleet in June 2019. 12th of June, after several days of rain, swollen rivers, we saw the relief channel. It wasn't the main river itself, it was the relief channel. Banks burst and caused flooding. Over 100 properties were flooded, 500 further properties and 1,000 people were evacuated, and about 1,500 acres of farmland was actually flooded out and crops lost. In a global context, that may seem a small amount, but when you add it up, that's one small catchment, and there are hundreds of these around the country. The impacts on those individual farmers was catastrophic, and that land, it's very close to where I live. I know I have friends who farm in that area. I have family who live in Wainfleet. That land is not recovered yet. It isn't a matter of, well, the water's gone, you can carry on, go back to farming. Yes, it was fresh water, it wasn't salt water, but we are still in a recovery phase on that river. Works are going on to improve the conveyance of the river so that more water is carried through. But we really do have to be thinking about whole catchments, because one of the problems that we perceive is that defences have been put quite rightly to defend houses, and there is nothing worse. I've met many people who have been flooded from their homes, and the time it takes them to get back into their houses and the mental stress on them has been extreme. Nothing worse than that. But we do have to be thinking in a wider context about how we adapt to the pressures that Ed talked about there, because I can assure you that this isn't going to be the last. 2007 floods, 2019, 2019-20. Ed talked about that winter. A lot of land flooded, a lot of farms. We saw this last winter in East Yorkshire, a lot of land flooded. And farmers are now finding that actually something that was talked about, and I think I want to talk a little bit about the terminology, because I don't think that's helped, because people have been told, oh, well, that was a 1 in 200 year event. That's a probability on that of 0.5 any year. It is not something that you can say, well, oh, we haven't flooded, we've been flooded this year, so we're not going to flood for another 199 years. That doesn't work like that. And many farmers are finding that their land is being flooded on a more frequent basis. And some farmers are finding that every year these tensions and this issue is happening. Why is this a problem? Why have we got to this situation where effectively floodplains are having to be recreated? Now, if you go back to our sort of post-war housing boom, a lot of floodplain has been built on in the last three-quarters of a century. And that has really caused, and of course, those houses now want protecting from flooding. And I can absolutely understand it's not the householder's fault, but we really do need to find room for the water, and we need to be working about whole catchments. Next slide, please, Heather. So this is more how the cost of that recovery in Wainfleet. RAF Chinook had to be brought in to bring 2 bags of material at a time. The cost of that to the country, £30,000 an hour. So when you think that there were 342 bags had to be brought in, and they were bringing 2, sometimes only 1, because the loading on the helicopter at a time, how many hours and the cost of that in terms of recovery? It isn't sensible to wait and say, well, we can just plug the gaps. And if that had been a coastal event, this is on a very small stretch of river on a relief channel. A coastal breach, I dread to think what it would take to actually plug the gap so that you could get the water out. But our point is that actually maintaining these catchments, and that isn't just about desilting, it's about a whole catchment approach. It's about natural flood risk management in the upper parts of the catchment, what is called slow the flow. It's also about storage areas. We're also a country, and Ed talked about that impact on the world, but also on this country. Our water resources in the east are very, very stretched. We have very little resilience. I was fortunate enough to be in Spain a couple of years ago when we could travel, we could go outside the house. And they were talking about 5 years worth of resilience to drought in terms of their water resources, both for home, so personal, commercial, and agriculture. And that's the sort of level that I think we need to start to think about building resilience in our infrastructure to actually make sure that these climate change impacts, I think, are already happening. We're just seeing the start. So what is happening now is going to be a more frequent events, more extreme events. And it isn't going to be just about, well, it's in the winter and we can hunker down. We're seeing 2007 June, Wainfleet June, high temperatures in the summer. We're seeing extreme rainfall events which are really impacting on communities. They're impacting, of course, on farmers, because at that time of year, these fields were full of growing crops. My friends had crops of peas, which were flooded out. Nothing survived being flooded, particularly in pea crops. Cereals, because the water was there for a considerable amount of time, because the cost and the time it took not only to plug the breach, but also to pump all that water back out on what is a gravity system sluiced out. It's pumped into the river, but the river itself goes into the North Sea via the Wash, via a sluice. And the answer is not, I think, to be looking and saying, well, we need bigger, more pumps, because we do have to be looking at the climate, the carbon impacts of all of this, and making sure we're managing our catchments in a better way by looking at the whole catchment and managing all of the resources and the environment as well. Next slide, please, Heather. So winter 19 saw further impacts. This is a pumping station of one of our local IDBs. You can see how far up the water's got there. So the pumps were submerged, electrical panels submerged. That took a large amount of money and a good deal of time of actually repairing that. That was water that had come out of the Witham system. So it was overtopping in areas into IDB watercourses. There were breaches in some of the local streams. Not the Witham itself, that would be a huge event, but we have seen really big impacts. And this is likely to be something that we're going to see on a regular basis unless we adapt and make more room for the water to actually be stored and potentially to be used at really dry times, or to be let back into the river so that it can then be transported out to sea. Next slide, please, Heather. So some of the issues that I've been talking about there, I think many people, particularly councillors on this call, will be aware about sustainable urban drainage systems. So basically, this is where developments have gone in, and we're absolutely supportive of that to make sure that new developments aren't impacting on flooding or really mitigating against further flooding. They're slowing the water up, and they're storing some of that water in the local areas. And what we're proposing is that actually that type of mentality and proposal can just have the same sort of impact in a rural area as it would do in an urban area. But it needs a real change in how funding's allocated, because at the moment funding is allocated by project, and rather than looking at a whole catchment approach, which is absolutely where we feel we want to be, is looking at whole catchments to make sure that actually you can be investing in areas that may be miles upstream, but still have a benefit for those urban communities further downstream, rather than at the moment where we invest in urban areas, we build defences, and we look at schemes to defend those communities, and the rural part, of the catchment are ignored. They're not properly maintained often, and we really have to move to a very different way of assessing that. And that's something where Lincolnshire, of course, we've been innovative in terms of our partnership working. really been a positive thing that actually working together with other flood authorities in Lincolnshire, we were absolutely at the forefront of that. And this catchment approach is something that we are working on in the steeping. I was asked to lead that recovery group, and really pleased at how farmers in the upper catchment are working with us on that to look at slow the flow type of approaches. We've got some of the other communities and the villages looking to try and work on that to make sure that the water's doing that. We've just completed phase 1 of desilting to not to deepen the river, but to ensure that there is enough depth to stop any reeds growing across the river, stopping conveyance, and also to make sure that that water can get down to the sluices at the end. But it's part 1 of a whole suite of actions right across the catchment. And that's something that we really want to see in all of our schemes, that type of mentality. Steeping's a very small catchment compared with some, but there's no reason why those principles couldn't be carried forward. Next slide, please, Heather. So we need to build that capacity. How can that be done? I think at the end of the day, it can be done in a number of ways. For many years, our drainage boards have been looking at creating berms within channels. So where there's, and we can see on this slide, where there are lower areas, so that in times of high flow, the rivers and the drains have got room to expand, but they also have a really good environmental benefit as well, because those areas for really good for water voles, and we're seeing that the number of water voles being counted across our Lincolnshire rivers and drains has dramatically increased. And actually, a lot of people tend to feel is, oh well, any of this work must be detrimental. I don't believe that. I absolutely counter that. I've seen on the steeping that the works that we've been doing already, the fish have really come back, and the fishermen have started to come back to the river, and they're saying how much cleaner the river is and how many more fish there are there than they thought there were before. And I think that's something that is really a way of building in capacity, but also making sure that the environment is protected as well. Next slide, please, Heather. So this is this 2-stage, clearer picture really of this 2-stage channels that can be done. Very simple to do, doesn't take up a great deal of space, but it means that those on low flows, you've got good flow of water, clean water, reeds potentially supporting the bank toes, really important, and only cleaning out one side at a time, so that there's plenty of room for nesting, plenty of room for wildlife to thrive within these systems, while at the same time you've got that capacity to make sure that we really are resilient to the effects that Ed talked about there. Next slide, please, Heather. So, at the end of the day, how can we ensure that if we're going to make room for water, that we're not going to impact on our food security that I talked about at the start? Because I think it's really important that we are aware that actually we need to keep producing food in Lincolnshire. We do have some of the best food producers here, and we need to make sure that we can do both. So we need to make room for the water. We need to make sure we are protecting the environment, but we're also producing food. Next slide, please, Heather. So what are our friends in the Netherlands doing about this? I was really fortunate in those days, if anybody can remember, when we could actually travel abroad without being fined £5,000. Really fortunate to go over to the Netherlands and see some of these schemes being built. 1995, they had some very serious river flooding. And of course, their coastal protection is exemplary. But in 1995, a lot of water came down main rivers, which come right across Europe, and a lot of flooding, a lot of communities and a lot of land flooded. So government said, we've got to do something about this. The channels of the rivers were seriously embanked, and it was evident that the rivers would keep bursting and keep flooding communities if something wasn't done. 2007, they started a scheme, 30 projects, 30 major projects across the Netherlands, costing 2.6 billion euros. It was completed in 2018, and I was really lucky to be able to go and actually see some of the works being completed. Next slide, please, Heather. So some of the principles about this is actually how can we make room, and the project is called, I'm certainly not going to try the pronunciation in Dutch system, but the project in English is called Room for the Rivers. And it really, the principles about that were to make more room and to actually take land on the sides of the rivers to actually make sure that on high flows, the rivers didn't burst, but they had room to expand and then go down as the levels receded. So next slide, please, Heather. So this was the project that I went to see, and this is a really interesting project because the farmers on this polder were told by the government that they had been identified as an area where they needed to make room for the river, and so the farmers went to the ministry and to the minister herself and said, we want to continue to farm this land, and we have an idea on how we can do this while still having that room for the river and having that flood resilience. And this is the what I talked about in being able to continue to produce food, but also having that resilience. And you can see these sort of almost sort of prehistoric looking type of embankments. They're about 2-3 hectares in size at the tops. They're up to 6 or 7 meters high. So right up at the top of, they're well out of the floodplain. So what the government did was that they bought the land, they leased back to farmers who wished to remain and continue to farm on this polder, and they built these plateaus of land for new farmhouses, for farm buildings to house livestock, for storage, for all the equipment and any seeds and fertilizers. And they said to the farmers, the deal was that you can lease this back, but we must have it available during the winter time. So between 31st of October and the 1st of March, the land has to be available to the national government to actually have that for a floodplain. And if it is needed during the summer, the farmers would then be compensated for any crops lost, and they would be given plenty of warning so that they could get their livestock up onto those plateaus out of the flood area. Farmers that we spoke to there were really, they said, well, as long as the deal sounded good, but as long as the modelling, I think really important that it really depended on how often they felt they were going to have to be flooded and how often. But the government, this is something that the farmers basically helped to co-design themselves. It wasn't imposed on them. This is something that so flood adaptation, good environment was built into this scheme as well, environmental areas, but also continuation of high grade farming. This was mostly an area of dairy production, milk production, and the farmers were actually getting a bonus and a premium for the milk produced off this area. Next slide, please, Heather. So this is something that we feel that actually, could be taken forward in this country. There are plenty of other examples across Europe of actually. We looked at some of the examples within the Rhine commissioners, how they've adapted, and it really is something that I think we need to be looking. It is great that we're investing from a national government, £5.2 billion in the next 6-year programme. And of course, that includes coastal defences as well. But we need to be thinking about how we spend that money, and we need to be making sure that we're really building in some resilience and adaptation to go forward. Next slide, please, Heather. So if you're going to do that, you need to have good water control structures, because what was clear, absolutely clear, when we went to the Netherlands and also in Germany, was that people are really the control structures and the infrastructure to get the water back off the land into the river when levels dropped was already built in to this and built as part of the cost and as part of the deal with the farmers. So infrastructure is absolutely key. Next slide, please, Heather. So this is the evacuating the water and having that infrastructure there. Some of it can be done by gravity, but you do need to have the infrastructure to remove those last bits of water. Next slide, please. So we need to make sure that this is something that is built into our mentality. At the moment, I think, we are still, we look at water resources in one silo, we look at flood risk management in another thing, we look at environment as being something else that we'll deliver separately. We need to be building all of these things in together and really building our infrastructure across the country, because if we don't, I'm really afraid that we are going to be having real problems with the impacts that Ed talked about. Next slide, please, Heather. That's the end of my slides for that. We've got a few slides on ADA itself, very quickly, or just to go through those. So we were established in 1937. Originally, our remit was to represent the internal drainage boards. Very much now we've expanded. We represent local authorities. We represent water companies. We also represent national agencies as well. So we're looking at the whole picture, and absolutely this is about making sure that we do want a low carbon future for that, and I absolutely support what Sir James Bevan was talking about. Thank you very much, Simon, and I'll take any questions.
That's super. Thanks, Robert. I mean that, and perhaps we can bring in Ed as well. Heather, that's fantastic. Thank you so much, and thank you for all you do as well on behalf of all of us. It's a really important job. I mean, one of my questions, I was really heartened to see the river steeping response, where you mentioned that farmers in the catchment are coming together to really look at that. How do you manage the governance of those catchment level systems? Because it's quite a challenge, isn't it? Because you got hundreds of stakeholders. You might have some stakeholders in very sensitive areas, which are really very important. How do you get everybody convening, and how do you govern that? It feels like the old challenge of managing the commons, and it's in everybody's interest to be engaged. But if you got, you could.
There has to be a willingness. There has to be a real willingness to engage with people right at the start, and building trust is really important on that, Simon, because actually, the farmers in the upper part of the catchment were really clear with us at the start. If you do some work across the whole catchment, and you can demonstrate to us that you're improving that conveyance, we're prepared to engage with you in the upper catchment. But what farmers didn't want to do, and I can absolutely understand that as a farmer myself, is to be, well, we're going to have to pay the whole price of this.
Yeah.
And this is our point, is that it has to be a whole catchment approach, and you have to build trust.
Yeah. Yeah, and it's quite a hard thing to do, isn't it?
Yeah, absolutely, and probably the hardest thing to do. It's very easy to sort of, the engineers can build you defences and things like that. Building trust is the hardest thing.
Yeah. Is that trust through contract, or is that
no, absolutely not. Absolutely not. No, it's trust through engagement, Simon.
Yeah.
It's engaging and talking to people. People are a lot more community minded than I think than even farmers, than talking as a farmer myself, than actually people probably realise.
Yeah, I agree. Yeah, no, I do agree. And things like elms, Robert, and catchment levels. So clearly there's a role there in terms.
Well, I think the whole of the sort of the way that government funding is going, sort of post CAP, for payment for public benefits, we see that as absolutely not just elms, but also in some of the other higher schemes, is actually how are you going to pay farmers for providing what is clearly a public benefit, and that'll be one of the ways. It is not. I mean, there has been a little bit of sort of CAP is not, the budget will not stretch to do everything that everybody thinks it can do. It isn't going to solve the climate. It isn't going to solve flooding and the environment, and keep supporting farming all at the same time.
Yeah,
but it can help. Help.
Yeah, will it create the leadership around this? I'm just sort of figuring who leads on this. This is another problem in catchment sensitive.
We're working really closely with farming organisations, NFU, CLA, on this. Wildlife trusts are really good. Local wildlife trusts are a really good partner as well. But it's that partnership approach which we've really set out in Lincolnshire. We're doing that on the coast as well, with Connected Coast Board, which was set up very much to look at just the funding from the Towns Fund, but actually it's really developed now into a partnership of organisations to look at the future of the coast.
Yeah. No, I've got a couple of questions in the chat. One's from Isabel. So Heather's going to post it. So really interesting talk. Thank you, Robert. Do you envisage the possibility of creating water storage that helps with flood for wet times and also provides water for irrigation in dry times?
Absolutely, Isabel. Water Resources East was set up absolutely to do that. That is the aim of that. We do have an issue because at the moment, silos of, if you invest in a flood storage reservoir, it's not about water storage. And this is where we have to get out of that. We have to look at UK PLC and the whole thing, not try and look at sort of, well, this is about flood, this is about water storage. But absolutely, that is what we are pushing for. There have been Felixstowe Peninsula. There was a small project which they're trying to get off the ground there. It took 7 years to get permissions from all the regulators. We can't be doing that. We've got to be thinking 7 months, not 7 years.
Yeah. Okay, I'm going to take one from Alan, if that's okay, Alan. So, question to both speakers. Given the difficulty of raising flood defences around the Wash and up into the rivers that feed it, should we be considering the old idea of a barrage across the Wash? Of course, it would solve energy renewable. You've got opportunity to generate renewable energies as well. But so barrage against.
I'll let Ed go first. Yeah.
Ed.
Yeah. So firstly, I'm not an expert on this, but I was very pleased to see that about on a slightly small scale, admittedly, the Boston Barrier floodgate fully operational within the last few months. In response to that, we've many of you would have directly experienced, but I showed a picture earlier in my talk that 2013 flooding in Boston, but other flooding episodes that have occurred there. I'm not an expert on flooding, but I do wonder about the conservation impacts of having a large scale system and whether it would protect surrounding areas. But I would have to defer, because I'm not a flood expert, I'd have to defer that we do have people in the university, Professor Mark Macklin, for example, who does a lot of work on that as well. So perhaps, Robert, you can fill in on some of the details here. So I would be a bit cautious. I mean, I think there'd be some pros and cons, I guess, but it'd be extremely expensive.
Yeah, it's not the first time, as Alan will know, that this has been mooted. It's this seems to be something that has had. We've had, I think, projects in the past to look at turning the Wash into a sort of water resources, all sorts of things. The nature conservation, under current legislation, you would have to replace that habitat, because you'd certainly be looking, so you'd have to find a new Wash somewhere else and build that first. So any suggestions on which county you would like to choose for that? I think at the end of the day, adapting our defences, and Alan will know that we've done some work on wash banks in terms of that, but the salt marshes are absolutely key. One, they're an incredibly good integral part of our flood defences. Two, they're a very, very good carbon sink as well. Salt marshes are absolutely key, and we have to be making sure that we are really looking after those. Anybody who farms on the coast will be aware of that, and we're still seeing some accretion in parts of the Wash. So I don't think, I'm not sure, I'm not convinced that that's the answer, but I do think I don't want to necessarily say, oh, well, definitely not, and then not have an alternative. But I think actually we do need to adapt and make sure, and this is what we're looking at on the Salt Fleet to Gibraltar Point strategy, which is being talked about and discussed at the moment, is where can we adapt?
Yeah. Alan just made a comment. So the Thames style barrier could keep the salt marshes. So you use it's almost as a barrier system to
Yeah.
get the water in and
Well,
out.
which, I mean, and Boston, the Boston barrier is a smaller version of that, of a rising gate barrier. There was one built in Ipswich. There's another one going to be built in the next few years in Bridgewater down in Somerset. £100 million a piece. There's been talk. I know there's been talk about a barrier on the Humber. You know, these are the wider you get, the more and more expensive they get, because obviously this commercial traffic has to be taken into account. But I think rising gate barriers, certainly on rivers, I think the Thames replacement, because the Thames barrier has been extended, but it's, you know, in the next 25 years, it will be at the end of its life. Replacement for that, we're probably looking at the entire flood risk budget.
Yeah, it's extraordinary amounts of money. There's one from Sean, but I'm apologies, Sean. I'm gonna have to close out, I'm afraid. And it's Sean makes a comment that floods bring high quality soil and silt to flood plans in the long term. How do we balance short term damage and floods and long term benefits of high quality soil deposition? Yeah, again, it's a great point, but I'm absolutely struck this morning at the quality of what we've heard. It's been a really extraordinary session, which I just really hope people really do tune in and listen to this on YouTube, because this is all about future. I was struck what you said earlier about 1 billion people, Robert, who are going to go hungry tonight because of poor nutrition, and the need to also to ensure we've got food security. So, and that's, I think, the really the complex issue in this dynamic. How do we protect the environment and ensure food security at the time?
They're not just hungry, Simon. You know, there's probably double that amount who are hungry. There's 1 billion people who are suffering from severe malnutrition.
Yeah,
they're not just sort of, well, I'm not sure we'll get a meal tonight. They are really suffering, and every year we get that bigger population. And yes, the waste is horrendous amount of waste going on, and we don't produce food in the right parts of the world. But with the climate change, when you look at the displacement of some populations, look at places like Bangladesh, majority of that country will be displaced with the sort of sea level rise that Edward's talking about.
Yeah, no, and I you know, on a home turf, and what I was saying, just in Lincolnshire, it's extraordinary, isn't it? And so we do have to deal with these problems, and we've got to, you know, and I can't help but think it's going to be collaboration on the scale that we've not seen before in terms of the way that we manage the environment and also food security. So I'm going to close out now, but I just want to again thank you, Robert. Thank you, Ed, for a fantastic event. That was superb. That's the last of our breakfast briefings for season 2021. I want to thank Heather, who's behind the scenes, who's organised everything. So thank you, Heather. You've done an amazing job. And everybody who's joined us through this season. And next up, we'll be really hope we're back at our home, the old hall at Riso, and back to a cup of coffee, a bacon sandwich, and a sausage roll. So to thank you again to everybody who's been involved, and on to season 21, 22. Good luck for the summer, everybody, and see you later in the year. Thank you very much. We'll close out.
Simon.
Thank you.